Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface, and in the previous lecture, we looked at how to design our own console input, the standard input, and then we saw that it was extremely easy. We just had to implement a few native methods based on what we want to have, either it's a string or an integer, float, double. And then in this tutorial, I'm going to basically do the same thing for the console output. So I'm going to create a new class called console out. And then here I'm just going to say again, we mentioned that for the standard IO, we don't need to open or close them. They are automatically opened for us when the process is run by the operating system. Therefore, I don't need to implement any auto closable or anything else. So I don't need to worry about opening or closing them. So what I need to do, again, I need to have my static initializer and load the dynamic library that is associated with this class, native_c. And then by convention, I'm going to have my private static native void init IDs. And we most likely are not going to initialize any IDs in the C++, but it's a good practice to have this anyways. And then for now, I'm going to allow for this console out to be basically to be instantiated. So public console out, and then in the constructor we're not going to do anything, and then we're just going to say, okay, I want to be able to output different types. So for example, when I say public basically native void print, and then in the print I'm going to say print an integer x, and then public native void print double x, and public native void print basically float x, and public native void print a string x. Alright, so these are basic print functions, and we can also have print line functions, so print ln functions, and we just do the same thing and then have ln at the end. We can also have these, implement these natively. And obviously we can have other things, for example object, and for the object, what we can do, we don't really need to do it natively, so we can say public void print and then object obj or x, and here we provide a body and say print we call this function print a string, so we call the x dot to a string. All right, and also the print line, public void print line, and then object x, and then call the print line function with the string. All right, and then call the to a string on the object. So this is how we can quickly set up our own console output for the standard output. And then all I have to do, I have to go to the C++ perspective, select my console out.java. So select my console out.java, and then click on the Java H tool, and it runs and creates the header file and puts it in my header folder of my C++ project. So this is the header file, init IDs, print, and note that the print is overloaded, right? These are native methods that are overloading. So let's just quickly recap of the signature of overloaded methods. What do we expect for the signature of the first one is Java underscore package name, which is test24 underscore class name, which is console out underscore method name underscore signifies overload and integer I, For the second one, it's a double, so underscore D. For the third one, it's float, so underscore F. And then for the last one is a string. So a string is an object, L semicolon, Java slash lang slash string, and then we said that a slash becomes underscore, and then semicolon becomes underscore 2. And obviously we have one more for the object itself, but this is not native, so it's we don't care about it. It doesn't have any signature because it's not a native method. All right, so print I, this is the integer one, print D, and print F, and then print L Java underscore lang string underscore 2. Underscore 2 is just semicolon, and then L semicolon signifies a Java object. All right, similarly for the print line, overloaded underscore underscore means this is an overloaded method in Java, integer, double, float, and L semicolon, which is an object. All right, so what we need to do, we need to go to our source folder here and then create a new C++ source file. I'm going to say console out.cpp. all right, and the very first thing that we do, we include our header file, include /header test24 console out, and then we copy and paste our function prototypes for this Java class, and then quickly provide a body implementation. So JNI environment, let's select this, and then command F and replace it with the JNI environment pointer. I call it JVM, and replace all. And then J class is the calling class because this is a static method. I call it console out underscore class. And then this init IDs for now doesn't have any body. We don't have any fields, anything here that we want to initialize. And then J object is console out, the instance of the object. So console out underscore obj. And I'm going to copy and paste this for all the other functions. J object, J object, J object, J object, and J object. So the first method is print, and then integer x, J int x. So what I'm going to do, obviously we need to get access to the native IO stream, console stream. So include IO stream. And then JInt is basically maps to a C++ primitive. So all we have to do is say stdcout. This is called the insertion operator, and then x. So this means push x to the standard output. All right. And then again, operator less than is overloaded for all primitive types of C++ and also the std string. So the next one, double x. We literally use the same code because it's overloaded for doubles. J double maps double. J float x, pretty much the same code again because it's overloaded. This operator is overloaded for float. J string is different, so we have to basically extract the C style string. So const char pointer basically x chars is JVM get a string utf chars, and then J string is x is copy, we don't care, but then it puts it on the native heap. So eventually we have to ask JVM to release a string utf chars, and then the pointer J string pointer is x, and then the character array is x. And then what we need to say stdcout and push to x chars. And again, this operator is also overloaded for the const char pointer. And then for the print line, what we're going to do, so JInt is x, and what we're going to say is stdcout push x, and also push std end line and ln. So end ln is just why is this complaining? Std and end line and l. So basically std end l is equivalent to basically \n. So we could just push \n, but end line also flushes the stream. So make sure that the stream is whatever we have before that. We may use a lot of different stuff here, and then when we use end line, it also flushes the entire thing. Make sure that everything is pushed to the console. All right. So note that we could very well use just the basically printf here, which is a C function, but I guess because the C++ provides the operator overloading, it's a nicer feature and we can easily use it. So for print line D, we literally use the same code here. So J double is X, and this is overloaded for the double, this operator, and then we add an end line. J float, the same thing, and then J string, we need to get the basically the const char. So same code here, but then we also push a std end line and l to the console. So that's it. We have the C++ implementation. Let's build this. It builds fine. Let's copy and paste our dynamic library to Java and overwrite the previous one. All right, so I'm going to the Java now. Let's create a new class, test console, the test console out, and let's have a main method here, and let's say test1, and here I'm going to say public static void test1. Let's create a let's say console out is new console out. All right, and then out that print line enter your name. So let's run this, and as you can see, it works fine. And right now we enter this, and then what we need to do is next we need to create a console in. In is my system dot in. Remember this, we turn this console in into a singleton, and that singleton is accessible via, did we have it via the, no, so the instance inside the console in is private. So the console in instance is only accessible via this my system class that we created, and it's just gets the instance of the console in. Because again, we want this eventually to be a singleton pattern. For each JVM, we only have, for each JVM that runs the one Java application, we only have one console that the user can interact with. So so enter your name, and a string name is in.next, which, and then we say out.println your name is plus name. So let's see if this works. Let's write Bob, and your name is Bob. All right. So this seems to work fine. Obviously, instead of using print line, I could use print, because I also provided a native method for print. The difference between print line and print is that for print line, we added a flush, end line flush, which basically flushes the stream of characters to the console and then moves to the next line. Let's go back to the CPP. So print overloaded with different double float, and we just push this value to the output, standard output. If it's print line, then we also push this end line to the console, which flushes the stream and then moves to the next line in the console. So so your name is so we can enter the name. So I changed this print line to print, so this should be basically at the yes. So this works. This doesn't move to the next line because we're not pushing the end line to the console stream. So Bob, and it says your name is Bob. And then what about the integers or doubles? So out dot print enter your age, and then in dot next int, and then this is basically our age, and then out dot print line your age is plus age. So enter your name Bob, your name is Bob, enter your age 21, your age is 21. Now obviously instead of integer, if I type a double, so 21.5, age automatically typecasts it to an integer, and it doesn't throw an exception. All right, this could be a good feature or bad feature depending on what you want to do with it. But the last thing that I want to do here is to change this into a singleton pattern. So private static console out instance, and then we make the constructor private, and then we have a public static console out get instance, and then this is a lazy initialization. So if instance is null, initialize it. Instance is new console out. Note that although the constructor is private, we can still call it because we are still within the scope of the class itself. And then return instance. All right, and then I go to my class, my system class, and then pretty much do the same thing. This is the entry point for accessing the output to the console out, and the type is also console out. All right, and then we go back here. Instead of instantiating this, I say my system.out, or basically console out is my system.out, and this code should still work fine. So we turn this into the singleton exactly the same way that the JDK designers designed the system.in and system.out. I just change it to my system. So my name is Bob and age is 21. All right, so the other thing that we can do in Eclipse IDE, we can create a template. Right now, the template for system.out is sysout, right? That's the template that we are used to. Print to the standard out, system.out.println. We can also create more or less the same thing. So Eclipse preferences, and then I can search for templates, and then Java templates, code templates, and then editor templates. And if we search for sysout, IJK, so there is a sysout here, system.out.println. Let's copy and paste this. Can I duplicate this? Maybe let's create a new one, and I'm going to call it my sysout, and then the description is let's see, print to my standard output, and then we're going to paste whatever we and instead of saying system, I say my system dot out dot println word selection. Okay, so let's see, I have my sysout, and then let's edit it. Context is Java statement. So what was the sysout? So the sysout is Java state. Okay, so now that I have a template, let's see if it works. So if I say my sysout, it's not easy to type it, my sysout, and my system.out.println, this is a template in Eclipse IDE. Yeah, so my sysout works, my sysout, and then control enter, and then I get my system out, and this out comes from my own console output class. So if I if I just try this code one more time. So what's your name? Bob. Enter your age, 21, and then this is a template in Eclipse ID. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.